So today we're going to divide polynomials using synthetic division, which is a shortcut, and it may seem simpler than long division, but it doesn't work on all of the polynomials where long division will. So synthetic division is a shortcut method to divide polynomials. This method only works when dividing by a binomial with a coefficient of 1. Okay? We divided by a lot of things yesterday. You can only use synthetic division if you have a binomial with a coefficient of 1 that you're dividing by. So if we look quickly at some of the questions we did yesterday, here when we divided by a binomial, but the coefficient was not 1. So I could not do this same problem with synthetic division. Here, we had a coefficient of 1, but this is not a binomial, so I could not use synthetic division on this. This one, it's a binomial. The coefficient is 1. I could have done long division or synthetic division. Okay? I mean, yesterday you didn't have a choice, but if this problem was to come up again, then you could choose either way. All right? We get on that? So be careful. You can't always just use it because you think you would rather do it that way. All right, so let's look at how this works. As a reminder, because this should be a review. On number 12, and the numbering makes no sense, just get over it, it's fine. We have this polynomial divided by this one. And so I don't use variables in synthetic division, so I'm not going to actually use this as the divisor. This is my factor, but my actual 0 would be -4, right? Like the solution to that would be -4. So inside, I take my polynomial that's my dividend, what I'm dividing into, and I use only the coefficients. So my coefficients are 1, -1, -27, and -28. And then I put this upside down dividing looking thing on it, and I box off the last part. Outside of it goes the -4. Everybody with me so far? Then the rest is pretty simple. Whatever this first one is, you just bring it down and it stays 1, or whatever it is. Then I take -4, multiply it by 1, I get -4. Then I combine those two and I get -5. Then -4 times -5 gives me a +20. Then I vertically combine those two and get -7. Then -4 times -7 is a -28. When I combine these two, I get 0. Okay? Oh, it is a +28. Yes. Because I wouldn't get 0, would I? I would get -56. Yes, I'm so sorry. Negative times negative is a positive. Thank you very much. All right, so I get 0. Not from what I had, but now I get 0. So let's talk about any questions about the process to get there, besides make sure you do it right. Okay. So then the 0 is the remainder. So since I have a 0 remainder, that means that divided evenly into it, right? And then this right here tells me what my answer is, what that remaining part is. And here's how you know what variables to put on it. There are 3 down there. There are 3 numbers down there, which means it is a second-degree polynomial. However many terms you have, 1 less is the actual degree. So that means this is the coefficient on my x squared term. Then it's -5x, then it's -7. And this is my answer. What questions do you have? Does that sound familiar? Yes. Okay, good. All right, so then let's look at, we're going to jump to number 15. So let's see what happens when our remainder is not 0. So once again, if I have x minus 3, that means x equals 3. What I write down to go on the inside are my coefficients. So I have 4, -16, 20, and -16. And then 3 goes out here, and I box off that last spot. So I bring down my 4. 3 times 4 is 12. I combine those, get negative 4. 3 times negative 4 is negative 12. Notice how I'm not changing the signs like I did with the long division, right? Vertically combine and I get 8. 3 times 8 is a positive 24. Vertically combine those and I get 8 again. So looking at the number, I have 3 numbers that I don't include their remainder. I've got 3 numbers there, which means it's a second degree polynomial. So this is 4x squared minus 4x plus 8. And then I have a remainder. So just like before, I add the remainder no matter what it looks like in there. 8 in the numerator. The denominator is not 3 because this isn't actually division. It's synthetic division. It is x minus 3, which is what I was really dividing by. Okay. What questions do you have? We good? All right. Now, let's see what happens when we have missing powers, because just like with our long division, if we have missing powers, then we have to take care of them. We can't just leave, just ignore them or things don't work out, right? So let's see. This is x cubed. So that should mean there are 4 numbers on the inside because it's a third degree polynomial. There's only 3 terms there. I'm missing my x squared term. So the coefficient of the x cubed is 1. The coefficient of x squared is 0. The coefficient of x is negative 49, and then my constant term is 120. Box that off. This means x equals negative 8. So negative 8 goes out there. Okay. See if you can divide that. So then you just combine those, so that's negative 8. There you go. Then you multiply negative 8 times negative 8. Put that number there. Okay, so I bring down my 1. There's a 1 there. Negative 8 times 1 is negative 8. When I combine these, I get negative 8. Then I do negative 8 times negative 8 is a positive 64. Combine those, I get a positive 15. Negative 8 times 15 is a negative number. 8 times 10 is 80. 8 times 5 is 40. When I add those, I get 120. And so then that zeroes out, and I don't have a remainder. I have 3 terms, so this is x squared minus 8x plus 15. So when we have a remainder, that tells us something. When we don't have a remainder, that tells us something. So when we don't have a remainder, that means x plus 8 is a factor of this polynomial. Like if I was going to factor it, that's one of the factors I would have. If I have a remainder, then that's not a factor, and that tells us something else when we're graphing that we'll get to in a little bit. Okay? What questions you got? All right, so let's look at 17. Go ahead and set up 17, like everything I have in purple on this one. You do for 17, and let's make sure that we can get it set up right before we move on any farther. Okay, so double check, make sure you agree with me before you move on. I'm missing the x squared term and the x term, so I have to put 2 zeros in there, all right? So if you're good with that, once you have that right, go ahead and divide and see if you can come up with your answer. How many of you are going through this feel like you're doing something wrong? Just because it looks weird doesn't mean it's wrong. Okay, just keep that in mind. Be confident in your steps. Yes, because if I bring down my 1, 9 times 1 is 9. Combine that, I get 0. 9 times 0 is 0. Combine, I get 0. 9 times 0 is 0. Combine, I get 0. 9 times 0 is 0. Combine, I get -1. So that looks like a hot mess of wrongness, but it's not. That's correct. So then you got to decide what is your exponent on your variable. You have 1, 2, 3, 4 terms. Technically there's 4 terms. So that means that is a third degree polynomial. So this is the exponent on the x cubed term. And then you don't have any of the rest because they're all zeros. You add your remainder, and that's -1 over something I can't see, x minus 9. What questions do you have? Okay, so we use long division and synthetic division for multiple different things. That's why we're going over this. But one of the things we can use it to help us with is to factor. So if you look at this example, I have this example, and it says to use division. But if I look at this right here, if I was going to not use division to factor it, I have 4 terms. So what process would I try to use here? Grouping. Does it look like grouping is going to work here? Like if I had, let's see, x cubed minus 5x squared plus 2x plus 8. So if I'm going to factor by grouping, I would factor out my x squared. That leaves me with x minus 5. Then I would factor out a 2, and that leaves me with x plus 4. So these don't match, right? And if they don't match, I can't go any farther. So even though grouping has worked on like everything you've tried, it doesn't work on absolutely everything. Okay? I'm giving you ones where it actually works. So I can't factor this one by grouping. So you're kind of stuck. But another option we have is to, if they give me a factor, which they did, they told me x minus 4 is a factor. So if I factored it, that would be one of them. This is just not going to work. So I know that x equals 4 is one of my zeros. I can use synthetic division basically to break this down a little bit. So we're going to do synthetic division just like we have been. So I'm going to use this. My coefficients are 1, -5, 2, and 8. And my 4 goes out here. Bring down my 1. 4 times 1 is 4. It's -1, -4, -2, -8, 0. Now, if I am told this is a factor, then my remainder better be 0. If it's not a factor. So if I didn't get 0 here, I did something wrong. Or, something's not right. So what this tells me here then is that this is my original f of x, but now I know that f of x, if I break it down a little bit, is actually x minus 4, the factor that they gave me, times what I got when I divided it out, which is x squared minus x minus 2. So it's partially factored now. Any questions about that? Can I now factor this? Yes, this I can factor. So f of x is equal to x minus 4 times, and then I can jump to 2 parentheses because that is 1, so this is x and x. The signs are opposite, and it's going to be a +1 and a -2. So this is my fully factored form, which it said, use division to write in factored form. Boom, there's factored form. Then once it's in factored form, I want the zeros, which is super easy. I would have -1, 2, and 4. Okay. What questions do you have? Anything? Okay. So now, you're going to try one. It says, given the polynomial function and one of its factors, use long division or synthetic division to write the polynomial in factored form. Then give the zeros of the function. All right, so you have an option, but if you can use synthetic division, I want you to use synthetic division. If we start with number 19, and can I use synthetic division on this one? Yes, so that's what I want you to do. So we have x minus 3, not x minus 3, I'm sorry, oh goodness, my brain. You know what I mean. X equals -3 is what I'm trying to say. So go ahead and do your synthetic division. But remember, when you're done, you're not just done. You've got to go from, write it in your factored form and continue factoring if necessary. If you are expected to factor and get zeros, what should your remainder be? 0. And if it's not 0, something ain't right. That is your fully factored form, right? Got to be able to factor that. If that means you go off to the side and factor by grouping, fine, go off to the side and factor by grouping. But that's what we should get, and the order of those factors don't matter. And then x equals, see, I'd have -3, -1/2, and 5. Okay. What questions do you have? Anything? All right. Number 20, can I use synthetic division here? No. So then what do I have to use? Long division. So let's do this one together. So we've got 2x plus 5. Oh, I never leave enough room at the top when I do this. Let me drop down a little bit. 2x plus 5 on the outside. On the inside, I've got 6x cubed plus x squared minus 27x plus 20. Okay. So 2x goes into 6x cubed, 3x squared times. So then that's 6x cubed plus 15x squared. On this one, I have to change my signs. All right, you go ahead and finish up this division part. And again, your remainder should be 0 because you know it's a factor. So the first step of your factored form, f of x equals, so I've got 2x plus 5 times 3x squared minus 7x plus 4. Then I need to factor that second one. So let me clarify something maybe for some of you as far as showing your work. Everything I do here, like vertically, has got to flow with this. So you can't just randomly in the middle just factor this part by grouping and then keep going again. Like your stuff has to be logical. But you don't have to show your work for grouping. I mean, I can factor this without doing that because I've been factoring forever. But you have to get to the next step. So that means you have to literally go off somewhere else, wherever you have room, okay, and do, all right, so I've got 3x squared minus 7x plus 4. 3 times 4 is 12. I need two numbers that are going to multiply to give me 12 and combine to give me a -7. So that's -3 and -4. So 3x squared minus 3x minus 4x plus 4. So then 3x times x minus 1, and then negative 4 times x minus 1. So I end up with x minus 1 times 3x minus 4, right? Then I'm going to take that and put that in right here. So now I have f of x equals 2x plus 5 times x minus 1 times 3x minus 4. That is your fully factored form. Then from that, you get your zeros. So I have negative 5/2, 1 4/3. What questions do you have? All right, if you don't have any questions, then you do 21 on your own. Can you use synthetic division on 21? Yes, then do synthetic division. Once I factor that 4-term thing with grouping, am I done factoring? No. So this is my fully factored form. Got plus or minus 2, and then negative 3/2 and 1. Okay. What questions you got? Anything? Alrighty, then your assignment is on Delta Math. You need paper, just like you did yesterday. You can't stare at it and try and do it that way. So go ahead and get to work on that, and let me know if you have any questions.